Today we are going to learn about a chapter which is called as calorimetry. Now we use a watch to measure time. We use a clinical thermometer to measure what's our temperature. But how do we measure the heat contained in a body? This is done by the called calorimetry, principle of calorimetry. For example, if I take say hot water and I drop few pieces of ice, what will happen after some time? Ice will gain heat, water, this hot water will lose heat, right? And after certain time t, I'll find that both of them has come to a particular temperature, right? We can measure. But what was the energy exchanged? How do we find out? For that, we use what is called as calorimetry. So, what does calorimetry says? Calorimetry says heat lost by hot body is equal to heat gained by cold body. Now there is a small thing, provided there is no heat which is exchanged in the atmosphere, which is lost in the atmosphere, right? So what does calorimetry says? Heat lost by the hot body is equal to heat gained by cold body, provided no heat is lost to the surroundings. Is this clear? Right? Now, let's take up an example. But before that, there is something called specific heat capacity. Let's understand this. Before that, let's understand a term which is called as heat capacity. Now say I have taken a big gallon of water and a small beaker which contains water. Both are at say 40 degrees Celsius. I am heating both of them and I am raising both the temperature to 50 degrees Celsius. Can you tell me who will reach to this 50 degrees Celsius faster? Will this gallon of water or will this beaker of water? Yes, obviously this will reach to the temperature fast. Reason? It has less mass. This has more mass. What do you mean by mass? More number of water molecules. So can I say the heat capacity of a body depends on mass? Clear? So it depends on mass. Now coming down to this term, specific heat capacity. Now let's compare water and let's compare copper. Now if I heat this water and I heat the copper, what happens? Copper will reach from 40 to 50 degrees Celsius much faster as compared to this. Why? There is a difference in the material. There is a difference in the material. This is water, this is copper. Clear? And that's what is included in in this specific heat capacity. Now let's understand this term, specific heat capacity. The definition says it is the amount of heat energy required to raise the temperature of 1 gram of a substance by 1 degree Celsius or 1 Kelvin. What does this definition say? It is the heat energy required to raise the temperature of 1 gram of substance by 1 degree Celsius or 1 Kelvin. Now there is a small thing which I want to tell you. Now it is 1 degree Celsius or 1 Kelvin. Now what is the freezing, at what temperature does ice form? 0 degree Celsius. If you convert this to Kelvin, it becomes 273 Kelvin. At what temperature water boils? 100 degrees Celsius. So what do you have? 373 Kelvin. What's the difference between these two temperatures? 100. What's the difference between these two temperatures? 100. So can I say that the change in degree Celsius is equal to in change in Kelvin? So if I say change in degree Celsius is 1, that means there is 1 Kelvin change in temperature. Is this point clear? Okay. Let's come down to that. Let's consider for this substance to be water. We say the specific heat capacity of water is 4.2 joules per gram per Kelvin. What does this mean? This means that if I need to raise 1 gram of water to 1 degree Celsius or 1 Kelvin, I need to supply 4.2 joules of energy. What energy? Heat energy. This number looks small, but it's a huge. That's the reason why water is called as it has high specific heat, and we use it in our car radiators, we use it in fermentation. There are many other applications, right?